Pythagoras is really famous for a theorem that bears his name, which states that if triangle ABC, so here's your triangle ABC, if that triangle is a right triangle, meaning it contains a 90-degree angle, in this case the 90-degree angle is right there, then a squared plus b squared has to equal c squared, where a and b are the lengths of the legs, and c is the length of the hypotenuse. C is right here, and the hypotenuse is directly across from the 90-degree angle. So you have side length A and side length B. It's important to note this only applies to a right triangle. Super important, right triangle. So what can you do with the Pythagorean theorem? Many things, but we're going to focus on two of them. One is calculating distances, and two, is this triangle a right triangle? We're going to answer that question. As a bonus, I highly recommend watching this video, What's Up with Pythagoras? Complete with a spelling error, Pythagoras. Which reminds me, it's really important that you know how to spell this dude's name. So What's Up with Pythagoras is a great video which talks about his life and some of the quirkier things about him. So let's first talk about, is this triangle a right triangle, and why the Pythagorean theorem is helpful. Well, this says that if triangle ABC is a right triangle, then this is true. The converse is that if this isn't true, then this is not a right triangle. And the forward direction says that if this is true, then it is a right triangle. So what does that mean? Well, for example, let's say I gave you this triangle and I didn't tell you if it's a right triangle or not, but I told you the side lengths are 3, 4, and 5. You take a look at these values and you square them all, 3 squared, 4 squared, and 5 squared, and you get 9, 16, and 25. You notice that 9 plus 16 is 25. This means that this triangle must be a right triangle. Yay, with a couple exclamation points. But let's say I changed it a little bit and I said this was 6, 2, and let's say 5. 2 squared, 5 squared, 6 squared, 4, 25, 36. Do any two of these values add up to the third? Well, the only possibility would be the two smaller ones adding up to the larger, and 4 plus 25 does not equal 36. So this is not a right triangle. 3, 4, 5, as we checked right here, 3, 4, 5 is the most common right triangle that you'll see, or the most common one that you'll get written down like that. There are others. So for example, here's another one, 5, 12, and 13. Is this a right triangle? Well, 5 squared, 12 squared, 13 squared, 25, 144, and 13 squared is 169. If you add these together, you are happy because you have an equation which is true, which is 169 equals 169. So this is a right triangle. And you know that the 90-degree angle is going to be across from the hypotenuse, which is the longest side. So that's the first thing you can do with the Pythagorean theorem, which is figure out if a triangle is a right triangle or not. The second really cool thing you can do with the Pythagorean theorem is calculate distances between 2 points. Let's say I had a point right here. Let's say that was at the point 1, 1. And let's say I had a point right here which was at the point 6, 4. And I wanted to know what the distance was between those 2 points. Well, I want to know the length of this segment. Considering that this is in the Pythagorean theorem section, you might suspect that you need to draw in a right triangle. So if I create a right triangle here, keep in mind I'm trying to find this distance, we can apply the Pythagorean theorem. Let's figure out how to do that. Well, first, we're trying to find this length. We'll call it C because it's the hypotenuse. We'll call this leg A and this leg B. As a side note, you could switch the labels for A and B, but generally it's good to put A on the bottom and B going up, but it doesn't really matter. And since this is a right triangle, we know that A squared plus B squared equals C squared. Remember that A and B and C are all lengths. So we need the length of A. How do we get that? Well, we know that A is horizontal distance. horizontal distance from here all the way to here. This point right here is 1, 1. The x value is 1. The x value here is x equals 6. We know that because of this value right there. How far is it from 1 to 6? Well, that's 6 minus 1, which is 5. Now we need the length of b. That's going to be vertical distance. So we're going again from 1, because of this 1 right there, all the way up to 4. How far is that? That's 4 minus 1, which is 3. So we now know that a is equal to 5 and b is equal to 3. And we can do some substitution. So if a is equal to 5, we get 5 squared, and we're plugging it into this equation, the Pythagorean equation, and we're adding to it 3 squared, which is our b value. Well, 3 is the b value, and we're squaring it, and that's going to equal c squared. So we get 25 plus 9 equals c squared, so 34 is equal to c squared. If we know that 34 is equal to c squared, we want to isolate c, which is the distance that we want, the length we want, so we're going to square root both sides. Square root both sides. So c is going to be equal to the square root of 34. You can do that on your calculator, and you end up with a value of about, and go to 3 decimal places. I like 3 decimal places, 5.831. You can check just by logic, does it make sense if that's 5, if a is 5 and this is 3? It has to be longer than 5. So 5.831 does seem to work. Let's try another example. Let's say the first point was 2, 1, and the other point was 7, 4. And we want to go from, measure this distance right here. This is our c value. So draw in your legs to make it a right triangle. What's the distance from here to here? The blue distance right there. Well, you're going from 2 all the way to 7. So that's 7 minus 2, which is 5, again. And this time we're going from 1 vertical all the way up to 4. So we go 4 minus 1 is 3. Looks familiar? 3 squared plus 5 squared is equal to c squared, c value. So c squared is equal to 9 plus 25, which is 34. And again, you got the square root of 34. So you can have the same distance many other places. Let's do one last one, just to make sure you understand what's going on. Let's say we went from 1, 3, all the way over to 9, let's say 7. Draw your distance in, just to make sure you can see it. This is your c value. And then draw in your legs, right angles right there. And you want the horizontal distance on the bottom. The horizontal distance goes from 1 to 9, so that's 9 minus 1 is 8. Your vertical distance goes from 7 all the way down to 3, so 7 minus 3 is 4. So you know that 8 squared plus 4 squared has to equal c squared. 64 plus 16 is c squared, and c squared therefore will equal 80. Square root both sides, you get c is equal to the square root of 80, which is about 8.944. Does that kind of check out? Over 8 up 4? Sure, it does. So you can calculate distance between any 2 points. One thing to keep in mind is distance is always positive. It's always positive. So if you're going from 1 to 9, that's a distance of 8. If you're going from 9 to 1, that's still a distance of 8. Distance is always positive. So, to summarize, the Pythagorean theorem says if a triangle, ABC is a right triangle, meaning it contains a 90-degree angle, then a squared plus b squared equals c squared, where a and b are the lengths of the legs of the triangle, and c is the length of the hypotenuse. You can check to see if a triangle is a right triangle to see if the sum of the squares of any 2 sides equals the square of the third. And if it doesn't equal any of the square of the third, then it's not a right triangle, as in this example right here. The second thing you can do is find the distance between any 2 points. You first need to find the horizontal distance, then you find the vertical distance, you square both, add them together, take the square root, and you can find your distance between any 2 points. I hope you found this helpful.